Hello, dear students. Today we have Proposition 34, Book 1, Proposition 34. In parallelogramic figures, the opposite sides are equal and the opposite angles are equal. In parallelogramic figures, the opposite sides are equal and the opposite angles are equal. Here we have a parallelogramic figure. It's given that this and this are parallel, and this are parallel. That's what you mean by a parallelogramic figure, where the opposite sides are parallel. This is a parallelogramic figure, it's given. Thus it is required to prove that the opposite sides are equal, this being equal to this, and this being equal to this, and the opposite angles are equal, this angle being equal to this angle, and this angle being equal to this angle. Let's get started. You can always use the transversal. It's called something else, I forgot. Something like a transversal. Okay? The diameter, that's what it's called, the diameter. Okay, so here we have then two parallel lines and a line falling upon them. Therefore, you know that the alternate angles are equal. Well, I forgot to tell you about the bag of knowledge today. We're going to use angle, side, angle, to show that the other sides are equal. We're going to use alternate angles, two parallel lines falling upon them, creating alternate angles equal to one another. We know that. And then we're also going to use side, angle, side. Two triangles with two sides equal to two sides and the angle they contain, respectively, being equal. The base will be equal to base, etc. Okay, side, angle, side. We know that. Great. So here we have two parallel lines and a straight line falling upon them. It's going to make alternate angles equal to one another. We've already proven that. So this angle is going to be equal to this angle. See that? Two parallel lines connecting them, forming these angles, alternate angles. They're necessarily equal. We've proven that. Likewise, because this is parallel to this, and a straight line is falling upon those two straight lines, it's going to create opposite angles equal to each other. Sorry, alternate angles equal to each other. So this one is going to be equal to this one. Okay? Great. Let's do a little hack mark there, maybe a squiggly line. Great. So here we have two triangles now, right? See those two triangles? And two sides being equal to two sides respectively, and the line connecting those two sides being equal because it's the same line, okay? So you see this triangle and this triangle. In this triangle, this angle is equal to this angle, and this angle is equal to this angle. Okay? And the line which connects the equal sides are equal, therefore, etc. Angle, side, angle. The sides opposite the angles we've proven are going to be equal to one another. So this and this, those two angles are equal, so the sides opposite them are also equal. Therefore, this line is equal to this line. We've proven that. Likewise here, this being opposite of this, and this being opposite of this, and these two being equal, these two sides are equal. Okay? Let's get a little blue marker here. Great. So now we've done the first part of the prop. We've shown that at any parallelogramic figure, the opposite sides are equal. Okay? Let's continue showing that the opposite angles are equal. Well, in side, angle, side, we show that the remaining sides are equal and the remaining angles are equal. The remaining angle, that is, of the third line here. So this and this triangle, from angle, side, angle, this is necessarily equal to this. Okay? We had two triangles such that two sides are equal to two sides, and the line connecting them were equal, therefore the remaining sides are equal and the remaining angle is equal. So this is equal to this. Well, look, these are opposite sides of this parallelogramic figure as well. So we just showed one part of the opposite, so let's say opposite sides, opposite angles of this parallelogramic figure. Okay? Now, what about this angle? Is this angle equal to this angle? Yes, of course, because this is equal to this and this is equal to this. Let's add equals to equals, and the holes will be equal. So therefore, this hole will be equal to this hole. and these are opposite angles in this parallelogramic figure. Thus, we have shown that in any parallelogramic figure, universal, the opposite sides are equal and the opposite angles are equal. Quod erat demonstrandum, which is to say, which was to be demonstrated. Thank you so much.